So Meta Research just released this model today. It is a translation model that is multimodal, so it does speech to text, text to speech, speech to speech, all that good stuff. And I just wanted to try it out in a Colab notebook. And I assume a few more people are going to want to do this. And there were a few little tweaks that I needed to make to get it to work. So I thought I'd just share that with you. So this is the official Facebook research repo. It has all the files and code that we need, along with some instructions on how to get the installation to work, and also a link to the model card. So you can see that there's two models available at the moment. We're going to use the smaller one just to be able to run it within the free tier of Google Colab. So if we click here, we get the Hugging Face model card. And you can see that transformers in and of itself is not enough, so we're going to need to import this package from the GitHub, and then there's a few code snippets here to get us started. So let's just jump right into it. Okay, so in Colab we want to make sure that we have some GPUs running. So if your hardware accelerator is just set to CPU, just change it to GPU and save, and that will just give us some resources to actually run Inference in a reasonable amount of time. The first thing that I needed to do to make this work was install a Conda version for Colab, and the reason is that as you can see in the repo here, there's a package that is required called libsoundfile, and I wasn't able to install that using pip. I was only able to do this using this command, and in order for that to run we need conda. So that's done. I'm going to install this package now. There's also these two packages that I needed to install to address other error messages that I was getting. And let's see what's next. Well, numpy and scipy should be pretty straightforward. And then we have we want to clone the repository and then install the code in the repository. So you can just do it like this in Colab. So this may take a moment, so I'm just going to pause the recording and I'll be right back. Okay, so that's all done. So now we can basically jump into loading the model, and here I'm just using the code snippet that was shared in the model card. However, you'll see that here there's no data type specified, and without that specified I was getting an error. It was telling me that that was a required argument. So what I did was I set it to a float 16. I think that it might work as well with the 32, but when I did that I ran out of memory within this Colab tier, which does make sense. So this is what I had to do to get this to work. I'm going to hit play. It now needs to download the entire model. So it'll take a moment, so I'll just pause and be right back. Okay, so now we should be able to run Inference. This is for text to speech and text, so that's what the T2ST means. We can specify a string that we want to translate and specify a target language, which in this case I'm going to use German or Deutsch. Note that there's the languages here, unlike for example in Whisper where there's only language codes with 2 letters. This is actually 3 letters, and you can find those all in the repo. So you can see all the different languages that are supported. I believe for text to text it's actually 100 languages, whereas for speech to speech it's on the order of 35 or 36. and we specify a source language as well. So this is not always required, but for depending on what modes you go between. What we'll receive is a translated text, so that will be a string, and then this is the audio, so there will be an array of torch floats, which is basically the audio information, and then a sample rate. So let's give this a try and just print the translated text. Okay, so we asked how are you, and we're getting wie geht's Ihnen. I can vouch for this translation, as German is my mother tongue. So in order to play with this a little bit more, I decided to make a little Gradio app and write these two functions. So one takes text and translates it to speech and text, and the other one takes audio and translates that to speech and text. So this you'll recognize, that's just the line that we did above. And in order to get the audio to work with Gradio, it actually needs to be in a tuple where the first element is an integer that has the sample rate, and then we need a NumPy array that has the audio information. So we need to basically just translate the torch array here into a NumPy array, and this isn't quite as straightforward, but it's also not as bad as it looks. So if you inspect this WAF variable, it's basically a list that just has one element with this float array. So we want to address that one element, and we need to basically make a copy in memory, detach and convert to NumPy. So if you're working with Torch a lot, you'll be familiar with this. And then I also found that we need to reshape this array in order for it to work properly with Gradio. And then we'll just return the text and our audio tuple. Okay, the translation from audio is ended up looking a little bit more complicated. I'm sure it can be done just as easily, but I was having some issues, and basically that arises from the fact that this function here for speech to speech and text is actually asking for a path to an audio file. I'm sure there's a way to also just take a torch array and a sample rate and just convert that directly, but I couldn't really figure out how to do that. So what I did was I took the audio recorded from Gradio, and I first wrote that to a WAV file. Now what was causing me problems was that that is being written with a sampling rate of 48,000, but our predict function here expects a WAV file that has a sampling rate of 16,000. So that's where this function comes in, where I'm now reading that file, downsampling it to 16,000 hertz, and then writing it again. So that's probably very inefficient and not very elegant, but it worked for me, and it helped with this issue. By the way, this is also only an issue if you're using Gradio, or if your file doesn't have a sampling rate of 16,000 hertz to begin with. Anyways, then we basically make the same call. I should point out that both of these functions also take the language as an argument, and that will be the target language. So by default, the source language in this for this little application will be English. Okay, so I just pip installed Gradio, but I decided to spare you the wait, and now I'll just quickly run the Gradio app so we can, as we're going through it line by line, we can have a look at the different objects in there, so it will make more sense. So what we have is we have a few little radio buttons here that just let us select a few different target languages, and then we have an input to record audio, as well as an input box for text. So if we type any sort of English in here, like let's say, "Hi, how are you doing?" Then we hit translate, and we should get the audio as well as a text translation here. So
Hallo, wie geht's dir?
the audio. So again, I can vouch that this is correct German. Let's try the same with Japanese.
ご用茶は様子ですか?
Now, I have no idea if that is accurate or not, but maybe somebody can tell me in the comments. Just for the fun of it, let's do that in Ukrainian as well. Alphabet certainly looks
Привіт,
reasonable.
як поживаєте?
There we go. That's that. And then we can do the same with an audio recording. So let's try something here. Hello, the weather is very nice today. So we've got our audio recording here, and we can translate. This actually, I think this takes a moment the first time we do it, but it's not as slow after that. So again, something.
Привіт, погодні дуже приємно.
Let's do German so I can check whether this actually makes sense. Yeah, you can see it took 10 seconds before, only about 2 now. So let's.
Hallo, das Wetter heute sehr schön.
Okay, so I find that the speech translation actually isn't super accurate all the time, but the text is pretty good. It's not that the speech translation is wrong, it's just sometimes omits a word or two. Anyway, so let's see how to create this functionality with Gradio. So basically what we have is this blocks interface. Gradio actually has a great documentation, so if you're not familiar, have a look at this blocks. This basically just sets up an interface. We then have our radio button here with our options for the different languages, and we call that len. Then we just have a row here with our audio in and audio out. Those are both just Gradio audio components, where the input has microphone as the source. Then we have our submit button, and below that we have a similar setup just with text boxes. So one will be our input, the other one will be our output. And all that we need to do now in terms of functionality is say that if somebody clicks the audio translate button, we'll execute our translate audio function, and will take as inputs the audio in, which can be recorded here via the microphone, and then the len radio buttons up here, and it will output the text and the audio to our two translation segments here. And the same thing just happens for translate here. So there's the second button, translate text here, and when that gets clicked, we execute our translate text function. Again, take the text as an input, as well as the value of the radio button, and output to the same two components here and here. So this is obviously not a great application, but we basically did everything end to end in terms of translation that one would need to, make this into a neat little app. I think this is super cool, and I'll definitely be playing around with it a little bit more. I haven't looked at the license. I don't think that this is licensed for commercial use, but it's certainly free for anyone to just play around with it and explore, and I think that's super cool. Anyways, I hope this was helpful. See you soon.